Welcome to While We Were Distracted, the podcast where we explore topics that often get overshadowed in the rush of daily life. Please take a moment to like and subscribe. It really helps.
Today we're tackling quite a story, an interstellar visitor that's become, well, maybe the strangest object we've ever tracked from another star system.
Yeah, and it's not just scientifically bizarre. It's also tangled up in this web of geopolitical drama, almost.
Exactly. It's like this information paradox wrapped up in a comet. You gave us some great sources looking at the really exotic science from Keck and TESS observations.
Right, and those sit right alongside the, let's call it, the high-stakes narrative that blew up around its close pass by Mars.
That's our mission for this deep dive. We want to kind of pull apart these two threads. You've got the hard science on one side,
And the speculation, the online theories on the other.
we need to understand why this object, 3I-ATLAS, is causing such a stir. Why is this third interstellar visitor just so fundamentally puzzling?
Okay, let's start with the basics, the established facts. It was discovered July 1st, 2025.
By the ATLAS telescope system, hence the name.
Correct. And the designation 3I tells you it's the third confirmed interstellar object. So it joins Oumuamua and 2I Borisov.
The I meaning interstellar. Its path proves it didn't come from around here.
Exactly. It's on a hyperbolic trajectory. Basically, it's moving way too fast to be captured by our sun's gravity. It's just passing through.
And way too fast is an understatement.
Right, yeah. At discovery, it was clocked at about 137,000 miles per hour.
Wow. So we're talking about a potential time capsule maybe billions of years old.
Just screaming through our solar system.
Okay, let's unpack the science first. Because even before the drama, this thing was weird. Weirder than Oumuamua or Borisov.
Definitely. It really started challenging our basic ideas about comets almost immediately. Let's talk about its tail, or tails, I should say.
Right, the anti-tail. That was confirmed by the Keck telescope in Hawaii.
Yes. Now, normally, a comet's tail points away from the sun. Solar wind, radiation pressure, pushes the gas and dust back. Standard comet stuff. But 3I-ATLAS developed this distinct secondary tail that pointed towards the sun. Completely the wrong way.
How does that even happen? Why would it do the opposite?
Well, the leading theory comes down to density. It suggests this anti-solar tail is made of much heavier, larger Duft grains.
Heavier grains.
Yeah. These particles aren't as easily pushed around by the sun's radiation pressure. Gravity plays a bigger role for them.
Ah. Okay.
So as a comet moves in its orbit, these heavier grains lag behind the nucleus along the orbital path. And from our perspective, especially Earth's perspective as it orbits, that trail can appear to point back towards the sun.
So it's an effect of particle size and gravity, basically.
It seems so. And it strongly suggests that whatever 3I-ATLAS is made of, it includes some unusually dense material that it's shedding.
Okay, that makes some kind of physical sense, but the chemistry. That seems to be the real wait what moment for scientists.
Absolutely. The gas plume data from Keck. That's where things got truly strange.
This is the nickel thing.
This is the nickel thing. The signatures show the gas was rich in nickel, but, and this is the key part, it had basically no iron.
No iron, just nickel. Isn't that wrong, chemically speaking?
It's incredibly unusual. We just don't see that elemental imbalance in other comets.
Yeah.
Not in our solar system, not in 2I Borisov. They usually have a mix, often more iron than nickel, if anything.
So what could cause that? Pure nickel, essentially.
Well, the spectral analysis points to a possible explanation, but it's a really rare one. It's a chemical process involving something called nickel carbonyl.
Nickel carbonyl. Doesn't that ring a bell from, like, industrial chemistry?
Exactly. That's the stunning part. Nickel carbonyl, NiCO4, is a compound we primarily see on Earth in industrial processes, specifically nickel refining.
So wait, are you saying this comet is doing industrial chemistry?
Well, not exactly like a factory, but it implies that the chemical conditions inside the comet's nucleus are bizarrely similar to those controlled industrial settings.
How so?
It suggests a very reduced environment, meaning very poor in oxygen, and likely specific temperatures and pressures near the surface of the nucleus.
Okay.
This might allow nickel to combine with carbon monoxide gas, forming this volatile nickel carbonyl, which then escapes. Crucially, it seems to escape without reacting with water ice, which would normally destroy it.
Wow. So its home star system must have had some very different conditions than ours.
That's the big implication. It completely expands our ideas about the chemical diversity out there between the stars.
Okay, so we have this exotic chemistry and anti-tail. But then the story gets even stranger with how inactive it seemed for a while.
That's the other half of the scientific puzzle, yes. Observations from TESS, the Transiting Exoplanet Survey Satellite, back in May and June 2025. They were confusing.
How so? What did TESS see or not see?
Well, researchers looked at its brightness profile, how the light spreads out from the center, and they found it looked almost identical to inactive objects like asteroids.
Meaning no coma, no fuzzy cloud around it.
No obvious, large, bright coma like you'd expect from a typical active comet, especially one getting closer to the sun.
But didn't TESS also say it was brighter than expected compared to earlier Hubble data?
Exactly, that's the contradiction. It looked inactive up close, yet overall it was brighter than predicted.
So what's the explanation for that? A tiny coma.
That's the idea. If there is a coma, but it's small or maybe just very diffuse, the TESS data suggests the dust within it is moving incredibly slowly.
How slowly?
Maybe a little as 10 meters per second, which is, well, it's practically crawling compared to the speeds dust usually gets ejected from comets.
Okay, so subdued activity, slow dust, weird chemistry. This thing is just fundamentally odd.
It really challenges our standard models of what a comet is and how it behaves. Activity's definitely happening, but it's weirdly lethargic, and the chemistry is unlike anything local.
Right, and this is the object that flew past Mars.
Just as things got complicated back here on Earth.
This is where the science story crashes into, well, beltway politics almost. The date everyone points to is October 3rd, 2025.
That was the day 3I-ATLAS made its closest approach to Mars. It passed within about 30 million kilometers.
Which is close enough, astronomically speaking, especially for the spacecraft we have at Mars.
Absolutely. This was the golden opportunity. Prime time for the Mars Reconnaissance Orbiter with its amazing high-rise camera, and the Perseverance rover using its cameras to potentially spot it in the Martian sky.
The dream scenario. Get detailed images, maybe even resolve features, see what this thing really looked like up close.
That was the hope.
And then what happened?
A U.S. government shutdown.
Yeah.
On that exact day, October 3rd.
Seriously, the very day of closest approach.
The very day. NASA's website, along with other federal sites, put up notices saying they wouldn't be updated due to a lapse in federal funding.
So no new data releases, no images from Mars.
Precisely when everyone was expecting them. It halted the public flow of information right at the peak moment of interest.
You can see why that would raise eyebrows.
Oh, immediately. The timing, whether it was sheer coincidence or not, looked suspicious to many people online. It created this information vacuum.
And speculation rushed in to fill it.
Massively.
Yeah.
You saw intense debate online, theories about a cover-up, a coordinated global information blackout. People started asking, what are they hiding?
This is where folks like Avi Loeb entered the conversation again, right?
Yeah.
Suggesting maybe it wasn't a comet at all.
Yes, his hypothesis that the object might be artificial, maybe some kind of alien probe sent to observe us, gained a lot of traction during that silence.
What fueled that specifically, beyond just the lack of data?
There were some unconfirmed reports, early analyses, maybe based on noisy or preliminary data, suggesting the object had this enormous projected length, like 50,000 kilometers.
50,000.
Yeah, but crucially, without a visible cometary tail in those initial, maybe flawed interpretations. So the narrative became, huge object, no tail, government silence. It must be artificial.
Even though later observations did confirm activity, that initial idea took root.
It really did. The lack of official, clear data allowed that speculation to dominate the early discussion.
And it wasn't just NASA's silence initially, was it? Weren't other space agencies also quiet?
For a short period, yes. There was a noticeable lack of immediate image releases from ESA, the European Space Agency, CNSA, China, JXA, Japan. This added fuel to the fire, prompting theories of some kind of global agreement to stay silent.
Like everyone decided not to talk about potential first contact?
That was the speculation.
Yeah.
But here's where we really need to bring in the technical realities and, frankly, the difficulty of seeing this thing.
Okay, so temper the speculation with some hard facts about observation.
Exactly. While the shutdown timing was unfortunate, the object itself was incredibly challenging to observe, especially from Mars orbit.
How challenging are we talking?
Well, ESA did eventually release images. Their ExoMars Trace Gas Orbiter, TGO, captured some on October 14th.
Okay, so data did come out eventually. What did it show?
It showed a faint, blurry white speck moving against the star background. That speck was the nucleus, and whatever minimal coma it had.
Faint and blurry doesn't sound very dramatic.
It wasn't. And here's the key number. The comet was estimated to be somewhere between 10,000 and 100,000 times fainter than Mars itself. which would have been nearby in the sky.
Whoa. Okay, that's incredibly faint. Like finding a firefly next to a searchlight?
A very good analogy. It was essentially a ghostly smudge. So the fact that those initial TGO images didn't detect a tail, that speaks volumes about how hard it was to see anything clearly.
So the silence might have been less conspiracy, more technical difficulty combined with bureaucracy.
It seems much more likely. Immense technical challenge, compounded by the shutdown, slowing down the processing and release of whatever data was trickling in.
That really puts the whole controversy into a different light. When you connect the dots, the object is scientifically weird, faint, hard to see.
And then you throw in a perfectly timed government shutdown. It's a recipe for making something seem far more mysterious or even sinister than the science alone might suggest.
Right. The lack of data amplified the strangeness.
Precisely. The object is genuinely scientifically fascinating on its own merits. Its narrative just got hijacked by terrestrial events.
But even setting aside the drama, the significance is huge. I saw Brian Cox called the whole story remarkable.
He did, and it's a great point. He highlighted the historical context.
Yeah, thinking about this object potentially forming maybe 7.5 billion years ago.
Possibly before our own sun and Earth even existed.
And now here we are, humanity, just 400 years after Kepler figured out planetary motion.
And we're capturing images of this ancient relic using orbiters we sent to another planet, Mars, and tracking it as it heads towards Jupiter.
When you put it like that, it's kind of mind-blowing. It's a real measure of how far we've come.
It truly puts our scientific capabilities into perspective. We're intercepting and studying messengers from the deep galactic past.
So what's next for 3I-ATLAS? Where is it heading now, and what are the plans to observe it?
Okay, its trajectory takes it outwards. Right now, actually, between October 21st and 29th, it's passing behind the sun from our point of view. So hidden for a bit.
A short blackout period.
Yeah, then it reappears and continues its journey out towards the gas giants. Next major milestone is Jupiter.
When will it reach Jupiter?
It's expected to make its closest pass to Jupiter in March 2026.
And we have assets out there waiting, right?
We do. The Jupiter Icy Moons Explorer, JUIC, which is on its way to the Jovian system, should get a good look.
What are scientists hoping JUIC will see?
Well, the hope is that the comet might become more active after its closest approach to the sun, perihelion. Sometimes comets wake up a bit more on the way out.
So UIC might catch it in a more active state than TESS or the Mars orbiters did.
That's the potential. Although it's important to note that data transmission time from JUICE is long. We probably won't get that data back until around February 2026, even if served earlier.
Patience is required. Are other telescopes still watching it?
Oh, yes. We're throwing everything we can at it when it's visible. Hubble, James Webb Space Telescope, Spherex, even Perseverance on Mars is likely still trying to catch glimpses when geometry allows.
It feels like this one object is really forcing a major rethink.
It absolutely is. 3I-ATLAS is dramatically expanding our understanding of what's possible out there in interstellar space. The sheer diversity of materials and formation conditions, it's pushing boundaries.
So let's try and recap the key takeaways for you listening at home. What defines 3I-ATLAS?
Okay, three main things stand out. First, its origin. It is confirmed, absolutely, to be interstellar from another star system. Its unique nature, the weird anti-solar tail, and especially that bizarre chemistry rich in nickel, virtually no iron. It breaks our local comet rulebook.
Okay, interstellar origin, unique chemistry and behavior. And third
is how its passage became intertwined with earthly events. The government shutdown happening right at the Mars flyby created this perfect storm for speculation and mystery, layering drama onto the genuine scientific puzzles.
It really highlights how science and, well, human affairs can sometimes collide in unexpected ways.
Definitely. And what's truly fascinating scientifically is how this single object is already making us question how common or rare our own solar system's chemical makeup might be.
Right. That nickel carbonyl finding suggests formation conditions very different from what built our planets and comets.
Our familiar iron-rich cosmic neighborhood might not be the galactic standard, at least not for volatile materials like those in comets.
That leads perfectly into a final thought for you to consider. We know 3I-ATLAS is ancient, maybe 7.5 billion years old, a time capsule from a different part of the galaxy's history.
And its chemistry is deeply strange to us, almost alien in its composition.
So here's the question to mull over. What percentage of the star-forming regions across the Milky Way over billions of years might produce comets with this kind of exotic, iron-free chemistry?
And perhaps the flip side, just how chemically unique or maybe even rare, is the stuff that formed our own solar system.
Something to think about. Thanks for joining us on this deep dive.
Don't forget to like and subscribe for the next episode on While We Were Distracted.